Okay. Check, check, 1, 2. Yeah, hello. Hello and remotely welcome everybody to today's session. Unfortunately, our company's current COVID policy is not allowing me to travel, so we are having a remote workshop today. However, I'm very happy to be a part of this year's Waves Festival edition. So first of all, thanks for having me here. And as far as I heard, there's more traffic happening on the live stream. So welcome everybody on a double remote way. So what will be the topics in the coming roughly 40 minutes? In the last months, we as Yamaha have held a series of workshops, webinars, and various advertorial campaigns focusing on getting a venue ready for live streaming. So let's consider today's session as part of this series, where we will focus on some mixing tips for live streaming from venues, which has become increasingly important in the course of this pandemic. As long as at least bigger audiences are not allowed inside clubs, streaming is the most attractive option if it's done well. So even after the pandemic, technology will continue to evolve and enhance the live experience. Already, streaming concerts from clubs is proving an attractive way for artists to perform. And in best case also reach even larger audiences. On the venue side of things, so venues are also benefiting from the increasingly easy to use technology, and the tendency goes towards always being ready to hold hybrid events. So this workshop shall provide some useful tips on how to mix audio for a live stream, and should give some suggestion on the kit needed for a successful streaming club event. Whereas the focus will be on the mixing tips. So yeah, let's have a quick look at the contents for today. So we will start off with a short intro and a very brief overview of the product of choice, or the product suggestion from our side. Then we'll run through a small possible systems setup example. And the main part, the art of mixing a live stream, features some useful tips and tricks in mixing sound for a live stream, and sheds a light on the differences between the approach to live sound and to live streaming sound, and how we should address, or how we could address them. And in the end, of course, we'll have some time left for questions and discussion. Yeah. So, who is it talking to you right now remotely from Hamburg in Germany? My name is Andreas. I have been working for Yamaha Pro Audio Business Unit as a product manager since 2016. And just on a side note, I'm native Austrian, so it's a double pity for me, of course, for not being able to come to Vienna personally. Yeah, just on the Yamaha Corporation itself is mostly known as the world's largest manufacturer of musical instruments, founded over 120 years ago already and headquartered in Hamamatsu in Japan. And the professional audio part of the business has been introduced roughly 50 years ago, and since then has brought many innovations and industry-leading products to the market, especially in loudspeakers and mixing consoles. For example, releasing the very first digital mixing console ever to the market over 30 years ago. You should see on the presentation on the right-hand side, the pic is showing the surface of Yamaha's DMP7 from 1987. So, as already initially stated, what's the application we're talking about? Streaming concerts from clubs is proving an attractive way for artists to perform and reach even larger audiences in best case. And venues are also benefiting from the increasingly easy-to-use technology. So in short, the technical demand on a band or a venue or a rental company, etc., is of course to be able to handle both live music and live streaming, and even more often both at a time, so-called hybrid events, which we are facing these days more and more. Today being a good example. So with maybe just staff or a limited audience inside the venue and a simultaneous live stream to the outside world. So what does that mean for us? That means that the gear and the other basic supplies, the demand of gear and other basic supplies, of course, is steadily increasing. And the good news from us, from a manufacturer perspective also, is of course that in general, technology continues to get more and more accessible and affordable. So the product I tend to base applications like this on is the TF series family of digital mixers. Of course, you could replace then these by any means of your choice. So the top mixing picks, of course, are valid generally. But nonetheless, the overall tagline of this product here is, for example, is to create a professional sound very, very fast, no matter what the application is, no matter what whether you are a seasoned audio engineer or if you are just still rather new to the topic. And to my opinion, it shows the increasing accessibility of such technology in a very impressive way. Just a few short details on that. It features the name-giving TouchFlow UI, which is a multi-touch interface with gesture control, and which we are all used to at some point nowadays. And it offers some very helpful features, such as a gain finder per channel, where on every channel it is helping you automatically to find the optimal gain setting. Then you have a consequent one-knob control options where you can influence several parameters of any processing with just a touch of a single button. It features a bunch of quick pro presets for most common microphones and respectively the applications, which Yamaha has developed together with our colleagues from Sennheiser or Shure or Audio-Technica, for example. And additionally, the opportunity to be networkable via the Dante audio network for even more sophisticated technical surroundings. But now let's have a look at a small system example. Let's assume a hypothetical venue. Let's assume a following application where we have some hypothetical streaming setup, pretty similar to what we are doing here today. Let's say the venue is the venue type is kind of a grassroots venue, a small club hosting a variety of different gigs, be it live bands, be it DJ events, be it spoken word performances, etc. And the operators can then be, of course, part-time or volunteer engineers, so not necessarily the seasoned and most experienced audio pro sitting behind the controls. And we assume, let's say, around 100 people capacity, and from a venue perspective, the demand on being ready to stream live is, of course, increasing, as I initially stated. So let's have a look on what kit we might need for such an application. Obviously, we need a sound source, which can be, as today, myself talking, or some other serious performance of the local hero rock band playing their set. We need, of course, to capture the audio performance, so we need some microphones and a suitable backline for the gig. And next, there is the camera sources, the video sources. The example here is mentioning, for example, a pair of GoPros, which, for example, would be a sufficient setup for a webinar or spoken word performance, like a webinar style or something. The camera count and the quality, of course, always depends then on the demand of the respective application, but just to get an idea on how these sources come together. And yeah, which leads us to the next part of the system, which is some kind of video mixer or switcher. For example, what you see here on the slide is a ATEM Mini Pro, or any similar device which can process all the HDMI sources and process the audio stream that's coming, that should be mixed with the video stream then. In most cases, as simple as the USB-C plug then connects the computer or the laptop being used for running, for example, as today Zoom or any other platform of choice to lead the stream to. But then, of course, again, the key thing we are talking about today is audio. So this could be, for example, as shown here, a TF5 console, as here on the slide. Very draftish, very simple from there. As you can see here, one very simple setup coming out of the would be coming out of the standard XLR left and right stereo outs of the mixing console, converting it down in that case to the mini jack audio in of the ATEM Mini. I mean, in a case like this, make sure to determine that the video device features a stereo input. Of course, there is way more elaborated setups out there, but the core is always to make sure that the audio stream quality coming into the video device or into the video mixer or switcher is as good as possible. And that's why we will have a closer look on some top mixing tips for live streaming right now. So how do we approach the audio mixing for a live stream best? It most definitely makes a difference whether you are mixing a live concert or sound for a live stream. For the live sound, you manage a PA system. For streaming, an isolated room with studio monitors or headphones in best case. I mean, don't get me wrong, this is all best case scenarios. For hybrid events, often a combination of both of the above is needed and is also the reality, but it's handled from the same mixing console, for example, on the audio domain. Just because there is not every venue has the chance to use two separate mixing environments for the different needs and stuff. Again, I know, of course, that in real life, for various reasons, this approach is not always possible, especially when it comes to hybrid events and the missing space and infrastructure and to follow this approach. But as a first recommendation, whenever possible, try to follow this different approach to live music. And on a side note, please, of course, do not consider today's content as the absolute wisdom on any occasion. It's rather consider them as some useful tips, and I tend to name this as just, let's say, thought provokers on the audio approach for the live stream. So it is, I think it is important to bring back into our minds, to remember ourselves that we are approaching the sound from a different angle than with a typical live show. But let's have a look at some of the main similarities and differences between live audio and audio streaming first. Again, just as a kind of thought provoker, that's why I have put them basically next to each other. At first, one of the most obvious differences is, of course, the live PA system and how we usually adapt the mix to the venue's characteristics just by nature, because we have to, if we have a loud PA system inside a venue. And because this doesn't necessarily translate well into a listening environment of a stream, where perhaps someone is listening on headphones, studio monitors, or some more casual living room setting, we have to, of course, be aware of this fact that we are approaching this on a different from a different angle. And then the next thing is to think about the stage volume versus the room acoustics, which can be, of course, both an advantage or a disadvantage for the mix. For example, if we have to mix a show in a large venue or a hall, it will sound very different than to a small capacity club venue. And especially for a stream, it would make a difference whether there is audience in or no audience in. Next point, further, mic bleed and feedback are quite important ones as well, because we might get away with bleed of sources on a loud stage or in a live scenario because it's loud and noisy, or lots of ambient noise anyway, whereas in a live stream, a lot of ambient noise is going to be really distracting in most cases. And yeah, the same applies for proper levels versus distortion, which will be way more distracting in a live stream scenario if any levels are too hot and clipping occurs, or if simply put the general audio level is not matching the final goal source for the stream. We will talk about this in a minute. Also about proper level metering and mutes versus fades. Also this we will mention in a minute anyway. So yeah, so what are these top mixing tips that should help to improve the sound of our stream? One of the first things to consider is adding some delay to the audio output. But why is that? We can see in this draft graph here, we can see both the video and the audio source are hitting the same target, which is ultimately the computer running the streaming software, right? So now for a streamed live show, the user should of course experience both video and audio in good quality, and above all in synchronization on all whatever the device might be, right? So due to the higher data rate or volume and greater processing performance in general required, video always needs more time than audio to arrive at the end target compared to the audio stream. And even though most streaming platforms and programs now have nowadays have some kind of automatic adjustment function, experience has shown that these are not always accurate enough. So you would still find that there is some drifting or anything happening. So in this case, we would need to align the audio at the output stage of the mixer, which, for just as an example, can easily be realized at the audio output on the TF console. Simply add some delay to the output metrics, and this is also just one factor or one part of the fact that I mentioned initially, where I'm basically boasting that technology has become very, very much accessible in the digital domain, in general. Yeah. So next, what is the next thing? The next thing, let's have a closer look on a more common audio processing practice, which is controlling the dynamics of an audio source by either compression or limiting. But before we control the dynamics, let's understand what the dynamics or the dynamic range, as a very common term, are. So namely, the difference between the loudest and the quietest part of a track is the dynamic range. Whenever we are using a compressor or a limiter, we intervene in this dynamic range, and thus we control its extent. And at any point of the audio journey, we have to be aware of the fact that we are basically editing the whole dynamic range. So let's look at this in a little more detail now. It is kind of a standard move to have a compressor on the channel, especially in the digital domain, because you don't need to have extensive outboard equipment anymore. But what does it actually do? Simply put, a compressor is used, as I already initially stated, to compress the dynamic range of audio. So it brings the louder and the quieter parts of any audio performance of any track closer together in terms of the general level. And we got two types of compression. We got downward compression, which attenuates the signal and is in fact a bit more common, I think. And we got upward compression, which boosts the signal until it gets to a certain level. Since there is a number of more parameters on the compressor, let's look a bit closer on them as well. Just for your reference, by the way, what you are seeing here on the slide is the interface of such a TF mixer when you have selected the compressor and activated the compressor on the audio channel. So what is the parameter threshold all about? It is actually the point at which the compressor activates according to the incoming signal. This level is set in dB or decibels, And how much compression we then apply is defined by the next parameter, which is called ratio. We can see a ratio setting here, for example, on the screen. Defining the stuff with ratio, a standard compressor will attenuate the signal to a level of 1 dB over the threshold for every X amount of dB it crosses. If we put this a bit simpler, or if we take this setting on the screen, I think it's quite small, but if we put this as an example, if the ratio is set to 3.5 to 1, as shown here in the picture, and the threshold is, let's just assume it's set to 0 dB, this means then that if the signal reaches 3.5 dB above the threshold, so in that case plus 3.5 dB, it will then be attenuated to 1 dB at the output stage in order to avoid clipping, for example. But more details will follow on that as well. Yeah. Then we'll also find parameters called knee and attack and release on any standard compressor, basically. The knee determines then how hard or soft, or in the case of TF, how medium, the compressor will work once the level of the audio has reached or has crossed the threshold, right? So compression in general can be overdone. We have to be aware of this as well, and cause distracting artifacts in our sound at some point. And the knee helps to reduce this effect and make it a bit easier to listen to. The attack and the release times, they are measured in milliseconds. They determine how quickly the compressor reacts once the signal level has crossed the threshold. The attack time is, in that case, then the amount of time the compressor will take to go from zero or no compression to full compression, which is then dictated by the ratio and threshold. Once the signal drops below this threshold, the compressor has to release again, and the release time determines how long it takes for the compressor to back down and stop compressing, essentially. And yeah, finally, then there's the makeup gain, and it's also often called simply output gain, as for example here on the TF console. Once the signal is compressed, we just learned that the loudest part of the signal becomes quieter, right? Therefore, to make up some short lows or gaps then in the total mix or in volume, the makeup or output gain could be used to amplify this again. So basically to sort of driving the compressor harder on the output stage. If we subsume this, so why is all this important to the output stage? Why is compression important on the output stage? Well, we are trying to catch those loud parts thrown at us by the band or the performers, and we can use compression to calm down those lively parts which tend to exceed some healthy levels, or of course to bring very quiet parts in the upward way more to level. All in all, it shall save us from clipping the audio stream to our streaming devices, which would then result in audible clicks and cracks or distorted elements on the end user side, and we of course want to avoid this. And it will also help to keep the mix tight and to sort of to keep it all together in an audio sense, in an audio field sense of a way. And since I mentioned also limiting, let's have quickly clarify the difference between limiting and let's say standard compression. A limiter is effectively a compressor with an extremely high ratio setting. It is designed to be used on the output stage only. So if we consider a whole mix of a band on the output stage only, and not on a single channel, just as a bass drum or a singer, for example. But what is the big advantage of such a limiter in a holistic mix kind of view? it allows us to bring up the total volume of an audio performance to a higher level without having the risk of peaking and thus distorting the signal. So generally, that's another fact for and another factor of especially. Generally, we as humans tend to find the louder the better. Or rather, we perceive louder tracks as the better sounding ones. So to a certain extent, a limiter helps to make the overall track sound fuller. But as with all of these processing techniques, of course, some experience is definitely required, because it can easily be overdone and then also basically cause the opposite and suck the life out of a mix and yeah, just make it sound odd, make it sound tiring. Yeah, but yeah, that's an overview about these specific and very common dynamic range processing technology. Then earlier I shortly mentioned muting versus fading. Though this is quite a simple one, but yet I think it's still worth to mention, especially as when we're coming from loud live mixing. We might just not have that present in our minds. Again, here is the thought-provoking fact. Because in a live scenario, we might just mute a channel if, for example, a singer has stopped singing or similar, or if there is some instrument swap or whatever the reason is, which actually seems pretty logical, right? Since there is so much other ambient noise and other loud signals going on live, we are also usually not recognizing a sudden closing of any single channel in the whole output mix, for example. But in a live stream, this is very much different. We are all kind of physically and also on a mental meta level, we are listening much closer to the sound in a quieter surrounding, usually with very much less ambient noise on both sides, on the production and on the recipient side. So yeah, if we then, for example, just mute by button, which is the touch of an on-off button, there is nothing to mask that sudden absence of the closed channel, and it might result in some weird sounding bit. So to avoid this, we should prefer fading of signals rather than muting, always of any signal when mixing for a live stream. For example, these would be any channel swaps or instrument swaps or longer instrument passages, etc. Small thing, but a big impact. Another top tip is thinking about room mics and the process of room miking. There is sort of two ways in approaching or thinking about this. Originally, we might have added, as indicated here in the graphic, originally we might have added a pair of ambient mics on either side of the stage pointed towards the audience. And this was, of course, for example, to help to improve the sound for any in-ear monitorings, which is becoming more common these days, and also to capture the audience ambience, for example, to enhance the feel for live recording. But now there is no audience, or way less, or just staff in the venue, or whatever the case is. So why would we then use ambient mics? Because listening to the mic and also the line signals of the band only, or of the performers only, it might sound somewhat soulless, and I think it might sound soulless, flat, and way too direct. And I think that we all unfortunately have experienced, especially streams like this, especially in the course of this pandemic in the last few months, when we were attending live streams from, I don't know, from local bands or from any other, or on any other occasion. And yeah, so I think this is a very valid point to consider, that we must not forget about this directness of just having the signals mixed together. So we still need some liveliness in the whole thing. And another thing is also that the room acoustics, basically every time in any venue, be it positive or negative, have some influence and might have added something more lively to the sound as well, to the whole mix. Just because there is, if we want it or not, there is an answer of the room in basically any mix. So what we would do is to anyway place ambient microphones, maybe not the left-right thing pointing towards the audience, but having something at the FOH or in the center, just to capture some of the ambience of the venue and aspects of the overall sound of the mix in the space, which will make the listeners, on the one hand, feel the listeners of the stream feel to be a bit more closer to the act, and not that as dry or as distant as it does without any ambience. And this might be just a really subtle addition. I ensure, that's the question that lies behind this quality control thing. So how do I ensure that I am hitting the video source device, if I'm responsible for audio, with enough audio signal, with the right amount of information? Before we do this, we need to understand what the meters are actually telling us. And the holistic view on it is just no rocket science. So the example here is it shows an analog scale, and it is measured in something called decibels U, dBu. This is just an analog reference because it refers to a certain voltage level, which is, I think I have put it on the screen. It's something like 0.775 volts, and has its roots back in the days of the invention of the telephone, basically. And traditionally, we will see scales like this on analog gear only, not on digital or hardware or software. But anyway, there might be hybrid consoles out there that we utilize to, I don't know, analog mixers that offer us, for example, a stereo out USB digital stream at some point that we can feed a stream with, or something like this. But in general, we will not see this in a small system setup as we are talking about today. Anyway, we need to understand from where it comes, and if we then, let's say we should expect to see the following. For example, here this is the output meter indicators of the TF console, and we should expect to see this everywhere is actually dBFS, or dB full scale, which is a digital measure of level. And it is a relative measure to digital full scale 0, the point from where clipping or digital distortion occurs. And in a minute, you will learn what is the difference between this 0 and the other 0. In the left-hand example of the TF mixer, you will also notice it having a range reaching from -60 to 0, changing from green to orange to red. On the top of the scale, you'll see the red indicators, which is when we reach this full-scale digital noise, commonly known as clipping, which is actually 0 dBFS. So this leaves us now with what levels shall we aim at, what scale is relevant. let's bring those two in context that we just saw. This is, I think, one more piece of important information. How is this analog scale translated into digital, just for our understanding when it comes to read or interpret meterings or meters? When comparing analog to digital, minus 18 dBFS and not 0 is the equivalent to 0 dBu. So these minus 18 dBFS should therefore always be our target output level, which leaves us then with these 18 dBFS of so-called headroom. I think you all have heard about this headroom and how important it is to have this headroom at hand, especially before the show starts. This way, when aiming at minus 18 dBFS, we basically reach then the analog standard level and still have some headroom in the overall mix before overdriving it. And same as here on the TF console, basically every digital scale has kind of the same color indicators. This point of minus 18 is, for example, when it switches from green to orange. Yeah. So let's subsume this to conclude on this quality control side of things. Basically, as I said, it's no rocket science. We have to just be aware that the metering or respectively its monitoring during the show and the adjustment are basically the be-all and end-all for quality control. So especially when mixing for a live stream, because here we have to make sure that our audio mix arrives at our video mixer switcher at a switcher at a sufficient level, and it's different to the live show where we instantly also have our ears on site. Basically the end product is happening somewhere else, and on so many various variations of different listening devices, right? But this at some point helps us then in the digital world or in streaming. We may have close to 100% have to talk about dBFS, and this makes it easy to compare the levels to match the leveling on the output and the throughput and the input side. So we should aim at not to reach the 0 dBFS, of course, because in this case, if it's reached or it doesn't necessarily need to be exceeded. It only needs to be reached, and it will create audible noises and deteriorate the quality's overall signal. And on the video side of things, or on the video software source side of things, a quick look into the software of our video program, for example, should also confirm dBFS on the level meter, and this way we can be sure that the same amount of information arrives there that we send from the audio output. Okay, unfortunately, as I just said, we can't do this in an all physical way, so that's the reason why I also unfortunately had to refrain from any audio examples, because it just would not work as smooth as it should in terms of the listening comparisons. So it seems we have reached the end of today's session already. At first, before we leave, many thanks again to the Waves Festival team for having us here. I just can double myself, because I really would have loved to come to Vienna. But yeah, maybe next year we will find us all in a better condition when it comes to traveling restrictions and stuff like this. I think we still have some time for question and answers now. I think we have some time, yeah. And I hope that I could shed generally some light on the whole topic, and in best case just brought some, as I'm not getting tired to mention, these thought provokers in approaching this kind of, or assessing this kind of different audio field for the live stream. And yeah, wish you all the best for your many future streaming projects, and thanks for listening. It's observing the input side of things, just as you can imagine the insert gain knob, and what it will then show you is kind of a stroboscope meter, which is looking like you might know it from a guitar tuner. So it will get greener and bigger, and then deteriorate again. So, and if you find the middle, basically you have your optimum setting. So this means that you basically, without any looking on details, you just see this this strobe wandering on your channel in side of things, and it also, if you do then, which is called a virtual sound check. So if you record signals, you can use them as well to automatically find then the gain on this respective channel. But that's basically the way this feature works. Okay. No problem. So I think we have all then, yeah, we have reached the end of this session, and we can yeah, grab some fresh brew before the next session. Thanks anyway for joining in. Thanks for having us once again, and yeah, I would pop out then and get myself as well a fresh brew.